So here we're going to talk about combinations versus permutations. And so how these are similar and how they're different. With permutations, as I have here in green, the order does matter. So what I mean by that is an example might be the number of unique passwords using the letters A, B, and C. So what I'm saying is if you chose A, B, C in that order, that would be one password. If you switch the B and the C around, then you'd have ACB. That's a completely different password. If you think about like a bike lock, sometimes you'll have bike locks that have 4 digits on it. If you have 1,234, that's different than 1,243. So there's BAC, there's BCA, there's CBA, there's CAB, and that's it. There are 6 different ways you can rearrange the letters A, B, and C to get a different unique password. So this would be an example of a permutation because the order in which you select the letters A, B, and C does matter. So for combinations, the order does not matter. So that means that each of these 6 things that we just talked about would be the same thing, A, B, and C. Think of it often as like picking a starting lineup for a team or something like that. All right, so an example might be the number of ways to select 3 letters from A, B, C, and D. So here I don't care how you select the 3 letters, as long as you just select those 3 letters. You could maybe think of it as selecting 3 friends to have a sleepover out of your 4 friends or something like that. So ABC, as I said before, is the exact same as CBA or BCA or BAC, you know, all those different combinations up here. So there are really only 4 possible choices. There's an A, a B, and a C, an A, a B, and a D, an A, a C, and a D, and then a B, a C, and a D. Basically, there's each of these choices are one of the letters is omitted. So this would be considered a combination where the order in which you select the letters doesn't matter. This ABC is the same as every way you can rearrange A, B, and C. So this is the first thing I wanted to talk about. The other thing I want to talk about is how can we calculate this? And so we're going to run through how to calculate permutations. And I'm going to show you a couple different calculators you can use to help through this if you want to use calculators. And one of them you have to buy and one's free online. So here's a permutation example, number of 3-letter passwords using the letters A, B, C, D, E, F, and G. So this is called the number of permutations of 3 objects taken from 7 objects. And what you'll often see is you'll see it written like this, 7P3. So this means a permutation of 7 objects where you're taking 3 of those objects. So if we kind of go back to when you first learned permutation or learn a problem like this, you might say, well, I have 3 bins I have to fill. This is the first letter for my password, so I have 7 choices for that first letter. And once I've chosen my first letter, let's pretend it's D. And now how many letters do I have? Well, I have 6 left. And then let's pretend I chose G. Now I have 5 remaining. So the answer to this would be 7 times 6 times 5. Well, rather than figuring that out each time, which, you know, is fine, it's not that complicated of a problem, but if you want a calculator to help you do this, there are permutation buttons. But the formula for this, just a refresher, would be 7 factorial, and then on the bottom it's 7 minus 3 factorial. So what this is, if you forgot what factorial means, that's 7 times 6 times 5 times 4 times 3 times 2 times 1. And 7 minus 3 is 4, so that would be 4 factorial, which is 4 times 3 times 2 times 1. So, since we have 4 times 3 times 2 times 1 on top and bottom, we can cancel those out, and we have exactly what we had up above there. Okay, so let's talk about a couple different calculators. The first one we're going to look at is a Texas Instruments TI-84 Plus calculator. This is one you can buy at most any store. Target, Walmart, Best Buy, whatever. So this calculator has a permutation button on it. And the way to get there is you hit the math button, and then you arrow over to probability, and the second one down is NPR. And so if I go down to number 2 and click enter, it pops up this permutation function. And so see how it's blinking here at the first one? I'm going to hit 7, and then I'm going to arrow over, and then it's blinking here on the second one. I'm going to hit 3 and hit enter. I got my answer. So we got 210. If I double check against what we did, it's 7 times 6 times 5. Is that 210? It sure is. Now, if you have an old model of a TI like 83, let's say, it might be an older version, there is one trick to this. For permutations, instead of going right to the NPR button, you will start by hitting 7, and then you go to math, and then you arrow over to probability, click NPR for permutation. You notice how we have a factorial as well. We could have done that. And it'll fill that first one in, and then you hit 3. So it might look a little different on an older calculator. You might have to do 7, and then it'll say NPR, and then 3. It won't have these subscripts here. Okay. Another option is a Desmos scientific calculator. So if you go to desmos.com/scientific, this also does permutations. It just looks a little different. So this is what it looks like. Right now we're on main. If I go over to function, here's NPR right here. And so the way I figured out how this works, and there might be another way to do it, but if I hit NPR, then I'm going to go back to main, and I'm going to do 7, 3. And so this is saying the exact same thing that we just did in the Texas Instruments calculator. It's saying 7 is going to be N, and R is going to be 3. So this ends up being 210, just like before. So many different schools will require you to get a Texas Instruments calculator, so I wanted to show you that method. If you don't have access to one, or you don't have it with you, this Desmos calculator is another great tool. This one is free online. The Texas Instruments one is not free online. All right, so let's go back and talk about combinations. And so a combination situation might be something like this: the number of 5 players starting lineups out of 12 players on a team. Now this would not, if you're thinking in terms of like basketball, you might have a point guard, a center, a power forward. Those are all different positions, but we're not talking about that. We're just saying you're picking 5 people to play in the game. It doesn't matter where they play. So that this would be considered a combination. And so much like with permutations, we have 12C5. And the way this one works, if you recall, this would be 12 factorial over 12 minus 5 factorial. It looks just like the permutation formula, except then you also do divided by 5 factorial. So this is a little bit more typing into the calculator, but if we use our Texas Instruments or Desmos calculator, we can make pretty quick work of that. So this time I'm going to do the same idea. I'm going to go to math, then I'm going to arrow over to probability, but this time I'm going down to C for combination. The NCR represents combinations. And this is 12C5. We're selecting 5 players on a team of 12, and that would be 792. If I go to Desmos, same idea. Make sure that we can do this. We'll clear this out. Go to function, hit NCR, and then I go back to main, or you can just use your keyboard if you're using like a computer or a Chromebook or something, and 12, 5, and we get 792. So a couple different ways you can find combinations and permutations using calculators here. All right, so this ends up being 792. So just to summarize, permutation formula, oftentimes you'll see it as NPR. This is n factorial over n minus r factorial. In permutations, the order does matter. We looked at ABC as different than ACB. And in combinations, that looks like NCR on a calculator sometimes. And there's the formula down there, n factorial over r factorial, n minus r factorial. And this is where the order does not matter. Think of this as like a starting lineup for a basketball team, or selecting some friends to have a sleepover, something like that. Hopefully that clarifies the difference between permutations and combinations.